Hi there, Akuma fans. Charlie with the Gossager Application staff. Today I'm making a video in response to a couple of comments that I had on the tool life management function for the Akuma milling centers. The tool life management function, if you viewed the other videos, they will track the amount of time that an individual tool is in a cut, or it will track the number of parts and or features that a tool makes. So the best use for the example I'm making today is a drill that I know can make a certain number of holes. So the observation and the questions that I got on the other video is that, okay, I see that if I tell this drill I can make 5 holes, then once it starts drilling, it'll count the number of holes. But if this expires, the Akuma software will wait. It'll flag the tool as no good, but it'll continue to use it until that tool is evacuated from the spindle. Then when it gets called for the next part or the next battery of holes, it will see that that tool is no good and either alert the operator or simply pick up a redundant tool if there's one that's available in the magazine. So the observation I got was, well, that's all well and good, but what happens if, say for instance, this drill is only capable of making 5 holes, but a single part has 10 holes to it? The Akuma software does not actively monitor the tool and stop using it once the tool life has expired. So the question is, how can I make that happen? So what I've done is I've written a little macro that I'd like to share with you guys today. It is advanced, but I have faith and confidence in my viewers that you can take a look at it, assess whether or not it's in your comfort zone and either use it or just say, no, I can't do that, and break up the number of holes that I have in my program so that I can let the software do the work for me. Let's start by going over to my actual part program and dissecting that. Here it is, drill.min. In my hypothetical, my drill is capable of making 5 holes, but my part has 10 holes. So let's open up the part program and dissect it one step at a time. First off, TLFON, tool life on. It's only important to specify that code once when the machine is powered on. Once it has been executed, then the tool life function will be on until I either shut it off with the code TLFOFF or I cycle power on the machine. At either way, it doesn't hurt to have it in the beginning of your program. It's nice. Now I know it's on. If I fail to do that after power on, my tool life function will not alarm out. It simply won't count the tools. So make sure you put that in there. I retract to a clearance plane. I'm using the tool change macro G116. Now I know that across the country and around the world there are different tool change macros that are being used. G111, G116, G119, several different ones. I'm just using G116 now, and I'd like you guys to just bear with me and substitute whatever tool change macro you're using. You could also use M6 in this case, but I prefer to use the tool change macro. So I'm putting tool 1 in the spindle because that's the master tool in my group. If you need a refresher on the tool life management, just search for keyword Akuma P300M TLM, tool life management, and my video on that will show up. Then I'm calling up my work offset, G15H1. I'm moving to the X0, Y0, which is the location of my first hole, turning on the spindle, reading the height offset, and as you probably know if you're familiar with tool life management, instead of saying G56H1 that corresponds with the tool number, I'm using HA, which means that I'm expecting the control to look at whatever tool is in the spindle and reading the height offset that corresponds to that. That's important if you're using redundant tools. Then I'm moving to a clearance plane of 100 thousandths above the top of the part. I do have a G71 or a retract plane of 2 inches. I've got some clamps apparently I have to pop over. So I'm setting my clearance plane there, turning on low pressure coolant and through the tool coolant. And then instead of using, I'm using G81 to drill these holes, but instead of calling it G81 here, I'm using the term mode in. This is a modal command, and what it means is that it is going to call whatever program is specified here every time I move to a new location until it reads the word mode out, modal out. So in essence, this is kind of like a user drilling cycle. If I were to use, say, G81 here with a stream of variables, you know that it'll execute a G81 at each of these X locations until it reads the code G80 or G0. Either one of those will cancel a modal drill cycle. So in essence, what I'm doing is I'm telling it, hey, I'm going to start a modal cycle that is represented in this program, OG101. You can name it whatever you want, but I chose OG101. And here's a stream of variables that I have written into that macro that we'll take a look at in just a second. First off, the PZ, that's equal to what's the depth of the hole that I want to make. PR is what is my retract plane. PF is what is the feed rate. And PM, is this going to be M53 or M54? Am I doing a clearance plane retract or am I doing a retract plane retract? So now let's go ahead and open up the OG101 SSB. Now notice that I'm using a different extension, file extension for this modal macro here. Not to beat a dead horse, but an SSB is a system sub program. And so it is designated as a macro. I could also call this a .lib, but then I have to go into some registration processes that you probably have seen on other videos. But let's go ahead and open up my sub macro here. The first line, whatever you have in the first line, has to match this O number right here next to my mode in, because that's how it knows which program to call. So mode in, I'm going to call G101. In my G101, let's take this line by line. Here's an explanation of how to make the call. And in this macro, I'm using G81. So I told it I'm going to do a G81 with a Z of whatever value was sent in PZ. My retract plane will be whatever was in PR. F feed rate will be whatever's in PF, and the M code will be either M53 or M54 depending on what was sent in the PM call. As soon as it does that one hole, I G0 to cancel the modal nature of the G81 cycle. I choose not to use G80 because, as many of you know, a G80 in a drilling cycle on an Akuma will turn off the spindle. It automatically turns it back on for a subsequent series of holes, but if you're moving from drilling to milling, the spindle will not turn back on and the whole darn thing stops. So I prefer to use G0 instead of G80 across the board because it cancels the drill cycle, but it will not shut off the spindle. So there's the G0. There I have a code TLCO, tool count. So what it did is it drilled a hole, and then this is going to increment my tool count for tool life management. Next statement is a conditional statement that says if variable tool life data number 4, this happens to be the good, no good flag for tool life management, and the value for whatever tool is in the spindle. That's what VTLCN represents, is the tool number that's in the spindle. If it equals 1, then skip to NALM1, sequence number NALM1. So let's assume that the tool life management is still good. It drilled a hole, it canceled the cycle, it then did a tool count. Now it's going to sample my tool life data and say if the tool life data is equal to 1. Well, it's not. 1 represents a no good tool, 0 represents a good tool. So because we still have holes available for this tool, it's going to read this and say if my tool life data for this tool number 1 is equal to 1, it doesn't. It equals 0. So that conditional will not be met. The next line is go to an end, which skips all the way down here and reads the RTS, or return to system. So it will read, let's trace it side by side. Mode in, it's going to call up these parameters and then make this G81 cycle occur at x0. Then the macro will dump out of the subroutine, move to x1, and do it again. Continue on with that until enough holes have been made to expire the tool. Now I know that this will make 5 holes, so after the 5th hole it will then expire the tool, and after it drills that, it says if VTLD, if my tool life management is expired, go to NALM1. This time it's going to skip around the go-to statement to the sequence number, and now I'm going to set a bunch of modals. By the way, if you need to know what these variables mean, or you want to look them up, look in your programming manual. The appendix has a table of system variables. I use it every day. It's handy as all get out, and you'll find a whole bunch of system variables that you can use during macro programming. Really makes life easy. I'll explain what I'm doing here so you don't have to go look it up now. Just know that they're there. PLP. This is just going to be a local variable. Akuma looks at any stream of unrecognized characters as a local variable. So I just put together some acronyms so that I would know what they mean. PLP in my head was for the variable for low pressure coolant. And so I assign the value to local variable PLP to whatever variable M code group 10 is. Group 10 represents the low pressure coolant M8, M9. So if the M8 is on when this macro is enacted, it will then set variable PLP to the value of VM code 10, which will be 8. If it were not on, that VM code for group 10 would be 0. PHP, or the high pressure coolant, is VM code 23. Group 23 is your M51. If the M51 or through tool coolant is on, that means it's going to assign local variable PHP to 51. Now, because we are dealing with an expired code, I then shut off the spindle. I'm going to do a tool change here. Even though I'm in the middle of this group of holes, shut off the spindle, assign a few more local variables, like PT is whatever the tool is that's in the spindle right now. In this case, it's tool number 1, so PT will become 1. PS is the VS code. That is the active spindle RPM. I just shut off the spindle. Oops, you know what? I probably should take that and make sure that I put it up above. Oops. There we go. We'll cut that out and we will paste it up above the M5. It should read it, but I'm a stickler for making sure that I don't contradict myself. There you go, PS code. Now we've got the spindle code saved to code PS. Shut off the spindle. PT is whatever is in whatever tool number is currently in the spindle. Then my PX, PY, and PZ. These are local variables that I'm setting to where the current machine position is now. And the way to make sure that you're doing that properly is to use VAPAX, which is the system variable for actual position, but that's in an encoder value. and I want to subtract Vm of x, which is the machine position. That's bringing the coordinate system into the machining envelope from the encoder position, and then subtract Vz of x VA code. That is my work coordinate. That is Vz of x represents what is my current active work coordinate x value for VA code, which is G15, H1, H2, H3. So what I did here is I assigned the x variable to my encoder x minus the machine x minus my work offset. So if, for instance, this expires at G15, H1, X4, that's what PX is going to represent, is X4 of G15, H1. Same thing for Y, same thing for Z. So now I've just basically told the macro, memorize where you are right now, because I'm about to move to go do a tool change, but I want to come back to that position. Now I have a G116T0. You could also do an M6T0, G111. That's my whole rant on the tool change macro. I have to get the no good tool out of the spindle. So I did that with a T0. Now the spindle is empty, and I'll repeat the command, the tool change command, but now I'll call up T equals PT. And if you recall, the PT is the active tool number. Because I'm using tool life management, that will be tool 1. Well, tool 1 is expired. So when this reads tool change macro T1, it will say, well, I would, but tool 1 is broken or no good, so I'm going to call up a redundant tool. Then we'll read the offset, that's G56, HA, read the height offset for the tool that I just put in the spindle, fire up the spindle at the variable that I assigned to PS, which was the previous RPM. Then I will position the machine to X equals the variable I set here, Y the variable I set here, and then I will start going through a little logic for coolant. If my low pressure variable, you saw that up here, that guy right there, if my low pressure variable equals 0, in other words I did not have M8 on, skip around the M8 call. If it did or didn't, it then delivers itself to the next sequence line, which samples the variable for high pressure. If that equals 0, that means that the through tool coolant was not on, and I want you to skip over the M51. But if it was on previously, light it up. And then I tell it to G0 or wrap it back to the variable that I set here, the previous location, and then end out of the macro. Wow, clear as mud, right? Let me get out of here, and I will save that, and I'll do a select and quit here. Let's go back to our tool data. I have two tools that are assigned to group number 1. Tool number 1 has 5 pieces available. I will set that to allow, it's a brand new tool, and I will set the okay. So now I have told it that tool number 1 is brand new. It's in group number 1. My management mode is count with a spare. It's capable of doing 5 holes. There are 5 remaining, which means it's okay, and I have 100% left over. Tool 15 is also in group 1. I'll make sure that that is a brand new tool, and it is in okay status. So now my tool life management is ready to go. Let's see how it works. Turn on my collision avoidance so I can see a picture of the machine. I don't have any work here, but yeah, you get the point. The two tools that I have used, I made drastically different so that you could physically see that it's calling up a separate tool. This one has an extension to it. This is my tool 15. So when I hit cycle slam, oops, we're in idle stop. There we go. So as soon as I hit cycle start, you're going to see it go up and change tools to the shorter. This is tool number 1, and we'll be able to see that here. And now I'm going to run through here. Here's my first hole. There's my second hole. There's the third hole. And there's the fourth hole. Let's do one more just for good measure. And now that tool's expired, so it's going to go into the subroutine, which then takes the thing, changes to tool number 15. Well, first it evacuated the spindle. Now I put tool 15 in. Now I got the long tool, and I'm continuing on. Even though my initial program, my actual part program, told it to do 10 consecutive holes. Now, because I've drilled 10 holes and I know that each tool is only capable of doing 5, let's go over to my tool data, and you'll notice that my no good flag is on for tool number 1, and I still have one hole remaining for tool 15. This is a little abnormality that I pointed out in the tool life management videos previously. The Okuma software will not expire at 0. It expires when you get to -1. So all this time I've been talking about doing 5 holes. I was actually doing 6. But the reason I wanted to do that is to show you that now I have one tool in the group that's completely expired and one that's only capable of 1 hole. I didn't notice it, so I hit cycle slam, started the next part, and this time, because there are no spares, it's going to burp, pop up and say, no, sorry, I have no good tools. So by doing this, you have basically created your own drilling cycle. I use G81, but you could also substitute G83 and make sure that your call variables have a Q value in them. Let's reset that alarm because I don't want to see that. And so the sky's the limit. You could do G81, you could do a G82, 83, 84, or 85 and track the tools in real time. I hope this helps you out. I do know that this is a very complicated and advanced macro. If you have any questions, please reach out to your Gosiger application staff. And you could also leave a comment on the video because I do answer those. Thanks for watching.